So let's move on to class. So last class we had discussed about what is right. So how to configure webhooks in repository side, and so what is right Jenkins share library, and how to configure Jenkins share library, and so once configuration is done, and how to reuse. So the main thing is reusability. So reusability means so we don't want to, for each project we don't want to write any script for scratch level. So if you some of common steps, some of repetitive steps, so that steps and all we are maintaining separate repository, and so we are creating one share library in Jenkins server, and once that is done, and we are going to reuse it in our script. Right how to reuse it and all with the help of art library we are giving your so we are giving your library name and all. And also webhooks. Webhooks mean nothing but so whenever new changes come to my repository, so automatically you want to right trigger the build. So that case we need to configure webhooks and all. So almost Jenkins part is done, and so if we have anyone any doubt, so I will so reiterate. If everything clear, so today we are going to start a new tool, and we'll see how it will work. Clear guys? Anyone any doubt? So Jenkins side. So already last class also I explained few of Jenkins questions. So those are the topmost Jenkins in interview. So 99%. So that is what is pipeline, and can you write pipeline stages and all, which stages you are using current project. What is Jenkins Jenkins master slave configuration, and how it will work, and how we are providing security over jobs, and how we are providing security over jobs, and how to create users, and right some of common steps and all. So and the main thing is pipelines, and Jenkins architecture master and slave, and so now remaining both are same, all are same options, right upstream jobs, downstream jobs, creating users, deleting users, and role based authentication with the help of we are giving permission to that particular resources and all. So these are main topics. Clear guys? Anyone any doubt? If it is clear, and today we'll start a new tool. Anyone any doubt? So Jenkins side, pipeline side, any errors, any issues, any challenges? Clear? Yes or not least?
Yeah, clear.
Okay. So in morning, so morning section, sir is explained what is Docker and all right. So now we are, I hope Docker completed or not yet completed. Who are join morning session? Anyone join morning? Joining or not? Morning.
Sir, not yet completed, sir.
Not yet completed. So almost half of completed, right? What is Docker, and how to create images, how to pull images, how to create image, how to create containers, how to stop, start, so some of
Yeah,
basic stuff and all, right?
that's and all completed.
Okay, so that's it. And so today I'm going to start so Kubernetes. So if you know, if somewhere if we say, if you know DevOps and all, so this is the one of the topmost, hotmost topic in DevOps. This is one of the topmost, hotmost topic in DevOps. So in DevOps, there is multiple tools already, right? So DevOps means this is not a single tool. So this is not a single tool. So DevOps means as of now already what is repository, GitHub and all. So what is repository, GitHub and all, and what is one build tool, Maven, and I will explain one more tool, Mant also. Later I will explain. And so right Jenkins, and already right AWS, I hope already completed, right? AWS, Linux also completed, right? Now Docker, right? Now Docker, now there is one more C is there, Ansible, and Also, we know, right? So we can see Kubernetes. Okay. So these are, and so intro mostly they will touch. So Jenkins, one cloud, any cloud. So AWS cloud and Linux is mandatory, and Docker and Ansible and Kubernetes. So Ansible, Docker, Kubernetes. So these are the topmost DevOps tool in intro purpose. 99%, 100%. So mostly they are asking this area only. Jenkins side, one cloud and Linux side, and so these are the Docker containerization part, and this is the configuration management tool, and Kubernetes also orchestration tool. Now already you know what is Docker and all, and how it will work, and how to create containers, and how to start containers, how to stop, and how to deploy containers and all. So this is right, this is right, on top of your host machine we are going to install your Docker, and with the help of that Docker, and so we can deploy your application. This is lightweight application, so no need to right. Someone is unmute, so can you put on mute please? Okay, let me share. Now I hope you know, right, what is Docker. Docker is nothing but this is a simple tool, right? So Docker, and so with the help of the Docker we are on top of. So these are the hierarchy. So if you go older days, so mostly we are using traditional deployment. So mostly we are using traditional deployment. Already you know how to create a application. This is the hardware devices, and this is the software operating system and all. On top of we are going to deploy. So we have some libraries, some frameworks and all. On top of mostly we are going to deploy your application. So if you go, this is right. So almost 15 years or 10 years back. So now later they realized. So we want to multiple applications, right? We have multiple applications. We want to deploy multiple applications, and how to handle this. If we have single application, no problem. If we have single application, for example, if you come to real time, right? So this is my organization. So just assume. So this is my organization. Organization means only one application or one project or multiple projects, right? So multiple projects. So nowadays, each organization they are maintaining, they are running multiple projects. But if you old days, so one or two projects they are, and they are deploying only single mission. Now, so this is only one instance, one operating system. So just assume right now this is my Windows operating system. So right now I am using Windows operating system. So right now I am using which operating system? Windows. So operating system. So Windows operating system. Windows OS. OS is nothing but operating system. And one second. I'm sorry, I got call from office. Yeah. So now if you come to here, so this is my organization. So in world of 20 days and 20 years, 30 years back, they are maintaining limited projects, and they have limited servers also. So this is my Windows server. So in this server, so they are deploy particular application, and so they can handle. So that is a standalone. Mostly the older days and all, they are maintaining standalone only. So nowadays all are web applications, and also all are right. So this is the microservice related. So even if 10 years back, mostly I work, this is the flow. This is the mostly I work with the web applications only, web applications. And so this is the monolithic application. Nowadays, monolithic, right? Monolithic entire package. We are grouping the package. So mostly we are getting war file, right? So as of now, only war file. So this is nothing but monolithic projects. So entire project, we are creating one package file, that is nothing but war file. And this war file I am deploying to my Tomcat server. Correct? Now the current situation, the current market. So most of the organizations they are using microservices. Anyway, we'll see later what is a microservice, what is monolithic and all. And so these are the hierarchy, how it will work. Now, later traditional deployment, later so we are using virtualized deployment. Now this is my operating system, Windows operating system. And here I want to maintain multiple. There is a hypervisor software. We need to install one hypervisor. So we need to install one hypervisor or simply VM machines. I hope many people know what is VM. So virtual machines. So for example, virtual machine. This is my Windows. With the help of VM, I can install multiple OS. So for example, I need one Linux machine. I need one Linux OS, Linux server, or I need one Ubuntu server. Both are same only, but flavor will change. Ubuntu server. So obviously just assume this is my laptop. So I have 16 GB RAM. I have 16 GB RAM, and so I have 500 GB hard disk. Just my laptop configuration. This is my laptop configuration. Now already Windows operating system is running. So for this operating system, right, there is minimum resources. We need to share minimum resources for running Windows and all. At least 4 GB RAM. At least 4 GB RAM I need, right? If I want to run Windows and all, 4 GB RAM and at least 50 GB hard disk. 50 GB hard disk space I need. Now I am using VM machines. Extra I need two more servers. One Linux server, one Ubuntu server. Now same like see here, this is my operating system. This is the hardware. This is my laptop. Just assume this is my laptop, hardware devices. On top of I am going to install the operating system. Right now here it is running one operating system, right? Windows operating system. I hope everyone know. So Windows operating system. Windows operating system. On top of I need to one more I need more servers. If you need more servers, so that case we need to install one hypervisor software, and that is nothing but virtual machines. So with the help of this software, so I am going to install one VM machine. I am going to install one more VM machine. Just assume this is the Linux machine. So for this Linux machine, if I want to run my Linux server, for this server also, there's we need to share some hardware devices. We need to share some RAM. We need to share some hard disk. Without this, it won't work. So for this server, just assume. So I need 4 GB RAM. I need 4 GB RAM, and for this server also, I need just or 50 GB hard disk. HDD. Okay. Now this is my Ubuntu server. So total I have 16 GB. So 4 GB I share to my Windows operating system. Next 4 GB I share to my Linux operating system. Next 4 GB I am sharing to my Ubuntu server. Now if we create like this, if we create many servers, if we create many servers, so obviously my server goes down, right? Clear or not? So this is my base OS. So this is my base OS. Now this is my laptop. Just assume same. So this is my laptop. On top of already Windows server is running, Windows operating system. On top of I need one more two servers. I need one more two machines for deployment purpose. For example, here I want to deploy Java project, or I want to deploy .NET project, or I need to deploy Salesforce project. So like this, I have multiple projects. For each project, so just assume for one for so for this Java, just assume. So for this, I am giving a Java project deployment, Linux server, Java projects, and so Ubuntu server, I am maintaining a .NET projects. Now, in same mission, if I configure this many servers, so what about performance of this server? It is working as usual, or else it will go down.
It will go down, sir.
Automatically, it will go down, right? So this is the main performance issue. Now,
Yes.
older days, we are maintaining this is very simple only. This is the hardware. Hardware is nothing but our laptop or desktop, whatever it may be. On top of we are using any operating system. That might be Windows or Linux or Ubuntu or Mac OS or CentOS, whatever it may be. On top of with the hype of hypervisor software, and I created two more servers. One server for see, this is also virtual machine. VM is nothing but virtual machine. This is the naming convention, guys. Just remember, in real time, almost all are calling VM. So don't confuse here. VM is nothing but virtual machine. So this is also one operating system. Don't confuse here. So in this, we are going to install one operating system. Here also one operating system. On top of we are going to So we are going to install your all your packages and all. On top of I am going to deploy my application. So anyway, like this, if I create, like this, if I create many servers on top of my operating system, so obviously server goes down. We are unable to handle, and also the one more thing is we need high configuration server. We need high configuration hardware devices. Clear? We need
Yes.
high configuration so hardware devices. So to overcome this problem, now I need, so for example, I want to create 10 virtual machines. So can I create 10 virtual machines because of this configuration? Is it possible? We can create, but it won't work. For opening page, it will take 1 or 2 minutes. If you click any button, it will take 1 minute. So it will work very slowly. That performance issue, main thing. Now to overcome this problem, now there is we are using Docker. You know, right? What is Docker? So this is same container deployment. So Docker is a platform for develop, deploy application with containerization format with containerization. Now this is my hardware. On top of I have operating system. Here no need to install any VM machines. So VM machines it will occupy more space, right? I don't want. I don't want. On top of operating system, simply we are going to install the Docker. Simply we are going to install the Docker. So with the help of Docker, we can create multiple containers. We can create multiple containers. What is container? You know, container is nothing but lightweight software to run your application. So generally, container means it is carrying multiple items, right? You know, right? Container in highway roads, most of the cases we are seeing containers, very big containers. So in that container, they are traveling bikes, they are traveling JCBs, cars. There is different items, right? Many items, correct? Now same way. So this is the container deployment. So this is my hardware. On top of I have base OS. That's it. This base OS might be Windows, or might be Linux, or might be whatever based on your requirement, based on company requirement, organization requirement. We are maintaining. So whatever it may be. On top of we are going to install the Docker. So what is the main advantage of Docker? It no need to share any resources. No need to share any resources. So now I have here a 16 GB RAM. Now if you come to here, this is my Docker containerization. This is my operating system. Here right now I am using Windows operating system or Linux. Just assume this is my Linux. Already you know, right? So are also using Linux operating system. So just assume this is the 2 GB RAM or 4 GB RAM. Anyway, we are using so AWS, right? 4 GB RAM and 2 CPUs we are using, correct? Two core processors. Now, so on top of we are going to install the Docker software. So while creating Docker software, did you share any hardware devices? So this much memory Docker need to use. This much memory, that is hard space we need to use. Did you specify anything while installing the Docker?
No, sir.
No. But if you come to here virtual machine, 100% you need to share your resources. How much RAM you need to share for this particular Linux server? How much hard disk we need to share for this server? We need to share resources, existing resources. So to overcome this problem, nowadays mostly we are using Docker. Nowadays mostly we are using Docker. Now what is Docker? So this is the existing kernel system. This is my operating system, right? So the technical name is kernel system. Kernel system. So here I have 4 GB RAM, and so here I have two core processor. Now, so this is my Docker, and here I am going to create containers. Now I am going to create one container. Now here I am going to create one more container. So in this container I deployed one application. So this is any application. So this is I deployed Java application, Java app. So in this container I deployed, so for example .NET or say whatever it may be, .NET. Now based on this application resource, what Docker will do? So Docker daemon will it using existing resources. No need to specify. If really needed, they will occupy existing resource. If they don't want minimal resources only, it will use. So that is the main advantage of Docker. So that is the main advantage of Docker. So no need to specify anything, and based on that application necessity, based on application requirement, and automatically this Docker using existing kernel systems, existing kernel. Now based on this Docker, we can create multiple containers. Now one more thing. So if we create multiple VM machines, so suppose for set up the VM machines also, it will take long time. Right? Already sir explained it. So if you want to create any virtual machine, at least it will take more time, 10 to 15 minutes. But if you want to create container within the minute, not minute, within the 2 3 seconds, we can create container. This is a lightweight. This is a heavyweight. It is occupying more space, and also and also we need to share existing resources and all. All right. But if you come to Docker, so these are the containers. Now we can create multiple containers, and whenever if we don't want, simply we can destroy also. This is also very simple for destroy the container. Right? Docker RM we are giving container ID. Automatically container will destroy. But if you want to remove the virtual machine, again we need to remove the entire operating system. We need to remove the hypervisor software. With the help of this hypervisor software, and we can remove this operating system VM machines and all. So already I hope already you have some idea what is Docker and all, and so what is difference between very very important. Interview also many people asking this question. So what is difference between VM, virtual VM deployment, and containerization, container deployment? So this is very so almost so many people asked this question. What is difference between VM machines and virtualization, and how it will work? Now see here, this is the hardware level process. Everything we need to share. This is the OS level. Already I have existing operating system. Already I have existing operating system. On top of we are going to simply install. And if each VM machine separate OS, for each VM has separate OS. For each container has can share existing operating system. And boot, if you want to connect this VM and all, it will take some minutes. But if you want to connect your containers, only seconds. And VMs are GBs. You want to it will occupy gigabyte, and it is occupying only KB and MB, megabyte, kilobyte. So this is the lightweight. So this is the very lightweight. It will occupy only KB and MB only. And so this is the read-only mode, and VM very difficult to find and remove. But here everything very simple only. Whatever you want, we can create. If you don't want, we can remove. And see here, VM can remove few hosts easily, and containers deployed and recreated rather than the removing. So here simply whenever you need we can remove, and whenever you need we can create, and we can destroy. Very simple format. And this is the longer time for creating VMs and all. It will take more time, at least 15 to 20 to 15 to 20 minutes. But only within the seconds we can create. So it will occupy more resources. That is means RAM, hard disk space, everything it is occupying more resources. But compared to VM, so containerization occupy very less resource. So this is very very important question. Just remember at least 2 to 3 points. General points. As of now, what points Just this is the lightweight, this is the heavyweight, this is the hardware level, process isolation, this is the OS level. For creating VM machines, it will take more time. For creating containers, it will take less time, and we can easily removing containers, and we can create recontainers. For VM and all, very difficult, and it will occupy more resource. It will occupy very less resource. There are some of basic, right? So this is very very important question. Interval also. Clear, guys? Hello.
Yes.
Okay, now let's move on to here. Now here what is a Docker, what is containers and all. Now there is one more advanced one is there. This is the this is the Kubernetes. Now I want to handle multiple Dockers. So how to handle multiple Dockers? Now as of now how to create a maze, how to create containers, correct? How to create containers, how to search the image, some of Docker commands and all. Now, the advanced level. So there is one more Docker Swarm, and also this is the advanced one, Kubernetes deployment. So nowadays, most of the companies, they are migrating only Kubernetes. So there is lot of features available in Kubernetes. And so next 1 week or 10 days, we are going to learn only Kubernetes. So, so if you, in your resume, if you mention Kubernetes, you will get more calls. If you are not mentioning Kubernetes, we are getting Kubernetes and Docker, we are getting very less calls. So now that this is that very, right? So topmost, this is simply we are calling a orchestration tool. So this is the content, Docker is the containerization, right? Containerization deployment. But if you come to Kubernetes, this is the orchestration tool, piece of code. We are going to deploy piece of code. So now see here, based on this image, you can easily understand. If you want to handle single Docker, go for containerization. I want to handle multiple Dockers, multiple containers. So how to handle? So that case we go for Kubernetes deployment, Kubernetes deployments. So Kubernetes. Now this is my application, right? There is two types of applications actually. So as of now we are using monolithic application. So what is that means? So the entire package and all we are going to deploy. This is the monolithic architecture. Monolithic means so as of now you know how to deploy Java web application and all. So now this is my project. Now let me come to here. This is my repository, right? So GitHub. This is the new terminology. Try to understand. This is very interesting also. Very important also. So now this is my project, right? So this is my Maven web application. This is my web project. Now, so once the build is done, here I am generating one file, right? Artifact file. Which format we are getting? Mostly artifact
Wow.
files and a war format. Now see here, if you understand this one. So this is the browser and this is the Apache and so this is the Apache server and this is Apache and with the help of this is a war file. War file means and this entire project we are going to develop only single file. The entire project we are going to implement only single file, right? That is nothing but artifact file. So the entire project. So we are using so already you know, right? So Maven web hyphen so app application dot war file I generated. So this is only single file. This is nothing but monolithic application. Monolithic means entire project I generated only one file. Entire project I generated only one file. So that file is nothing but so war file. Mostly we are using war. See, this is and I deployed into Tomcat server and deployed into Tomcat server and with the help of Tomcat server whether my application is running or not already we checked many times. So this is simply if you remember what is monolithic architecture means entire project we are going to generate only one file. We are going to generate only one file. So what that file? War file. Mostly we are using real time war or ER or sometimes jar also. That is based on our requirement. So if you are using any Spring Boot project and all, so that case we are generating jar also. So mostly we are using three types, right? Yeah, var, WebArchive, jar. We are using so jar, var or ER. These are the three types. So whether we can generate a jar file or var file or ER file. So once war file is generated, I want to test my application. So where we need to deploy Tomcat server. These all are the web applications, right? So these all are the web applications. So without server, it won't work. Web applications and all web application, correct? So without server, so it won't. We cannot deploy. It cannot work. We cannot check your product how it will work. So might be this we are using multiple servers. So mostly we are using Apache Tomcat server for Java purpose. Apache Tomcat server. These are the servers. Java people they are using these many servers. WebLogic server, WebLogic server, and we can use a JBoss server. JBoss server. This is based on project requirement, client requirement only. So WebLogic, JBoss server, Jetty server. So there is multiple servers available in market. So based on client requirement and based on project requirement, anyway we are going to use one server. But .NET people and all they are using only one server, that is the IAS server IaaS server. And so for if you come to Salesforce and all, they are using different server. That is naming convention is sandbox. That naming convention is sandbox. All are same purpose only, but deployment only it will change. Java people, we are deploying different way. .NET people, they are deploying different way. Here mostly they are using IA server and Salesforce. This is also same like Java only, but so they are going to deploy and sandboxes. For each developer we have some sandboxes for each environment, and so we are going to deploy that particular environment. We are going to deploy that particular environment only. We are going to deploy only that particular environment. Okay, so these are the naming convention. Just try to remember. And so real time mostly we are listening daily. We are hear these words. So what is IA server? What is sandbox? What are the WebLogic, Tomcat server, JBoss server, Jetty server? So in market, different kinds of servers available, but all server purpose is same only. All right. So all server purpose is same only. So we want to deploy your application and we need to check it. That's it. So clear, guys? Anyone any doubt as of now? So these are the monolithic. Monolithic means so the entire project we are going to generate only one var file, and we are going to deploy any server. But there is one more is there, microservices architecture. So nowadays almost all are migrating microservice only. Microservice means so we are going to deploy, we are separating each model. So now if we come to here, so here this is the one model, this is the storefront UI model, this is the account service one model, inventory service one model, shipping service is one model. But all models we are generating only one file, var file, and we are deploying. Now see here one disadvantage, there is one great disadvantage is now right, if you modified this model, again we need to generate the entire project var file, again we need to build it, again we need to generate the var file. Now got it? For example, so just now I updated only this model, but I modified only this model. But how to update this code, how to check it this whether it is working or not, again we need to generate the new var file. If any changes happening any model, and so we need to generate the var file and we need to deploy this any servers and all. Now to overcome this problem, I don't want to disturb other models. So that case, so we are using microservices architecture. So now Kubernetes 100% following microservices. So Kubernetes following only microservice architecture. Now if you know Kubernetes, now we can deploy like this. Now see here, this is the account model. This is the inventory model. This is the shipping model. This is the DB. This is inventory DB. This is shipping DB. This is the API application program interface. This is the front end gateway. This is the storefront web application. This is the REST API. This is the browser. This is the mobile related application. This is the desktop related application. Okay. So now if you modified anything, so no need to touch all these things. Only we are going to update this particular model and we are redeploying it. We are redeploying it. But how these all models communicate each other with the help of REST API. With the help of REST API. So this is the web services actually. So this is the help of this REST API. If anyone know Java, .NET, they can easily understand what is REST API and how this REST API interact with each model and how it is connecting each other. But if you don't know, leave it. So slowly we can understand. Okay. So these are the mobile related. This is the desktop. Now it from this, I want to connect with the account service, or I want to connect with inventory service, or I want to connect with shipping service. From shipping, I want to DB. So actually, this is the flow. And if you come to nowadays, all application are MEC application. MEC, model view controller. So model view controller. So I am the end user. So I am the end user. Just assume this is the browser. I am the browser. This is the browser. I am entering some content, right? So this is the browser. So now this is the controller. And so browser, if you send, this is the mod view. In there is one layer is there. This is the view layer, and this is the controller layer, and this is the backend layer. So if you send any request, first it will go to view model. On view model, it is interactive with the controller, and controller it is interactive with the DB, and the same way the output come back to your browser. The output again it will check DB and it is checking controller. Again it is coming to your browser. So this way it is working. So this is the MEC model view controller. This is a web application architecture and all. So you don't worry if you any developer. So developer 100% they need to understand. They need to understand this flow and all. But you are not a developer. You don't worry. If you understand this flow, this is very simple. You can mostly we can understand. Oh, what is this application and what is the hierarchy and how it will work. So this is the view. This is the model. This is the database. This is the backend. Simply we are calling a DB. So without DB, there is no application. Without DB, there is no application, right? If you go ATM, just it is asking, so right, password, PIN number. If you give your PIN number, so that this is the browser, right? This is the front end. This is the front end UI level, user interface. Simply we are calling UI, user interface. This is the UI. If you send any request, so this is the UI. If you send any request and the request go to view model, that is the in front what view you can see. Now if you insert your card, it is asking PIN number. If you enter your PIN number, something, if you enter your PIN number, so that will go to controller. So this related class, so there is one class is there. This class will take care and this class interact with the DB. So based on your DB, it is checking same number it is matched or not. Same number it is matched or not. If it is matched, it will redirect to another page. If it is not matched, what it will happen? So incorrect PIN number. Please re-enter PIN number. We are getting one error message. Clear? So this is actually application flow and all. This is the model. This is the web application flow and all. Based on this only, it will execute. If you understand, so this is very simple. If you not understand, leave it. This is not our duty. We are not a developer. We are the DevOps engineer. Our roles and right activities and all different. So anyone any doubt here? Now these are the microservice architecture. So nowadays Kubernetes following microservices. Microservice is nothing but the entire project we are going to split multiple models. The entire project we are going to split multiple models. And if you want to modify anything, so simply we are going to modify this particular model. And so we are going to right, we are going to so we are going to modify only particular model, and only this model we are going to deploy it. No need to touch other models. So no need to touch other models. This is the main advantage of microservices. So main advantage. So compared to monolithic, right, that if you modify anything, again we need to generate the new war file. Again we need to generate the new war file, entire project. But here not like this. So which area you modified? Which area you modified? Only that area only. Again we can redeploy, update and redeploy. That's it. Now very simple, right? We can easily modify any model. Whatever. If you want to, we can update this one. Or if you want to, we can update this one. Or if you want to, we can update this one. That's it. Very simple only. I hope now we got some idea, right? So what is monolithic application and how it will work, and what is microservices? What is microservices? This is the microservices architecture. So Kubernetes 100% following microservice architecture. So we are going to split multiple models and we can easily deploy. And if something goes wrong, and we can which area it is failed, only that model only again we are redeploying and retesting it. No need to check, no need to deploy all models. So this is the one of the great advantage of microservices architecture. Clear guys? Anyone any doubt? So this is only initial. This is the high level only. Anyway, slowly we will learn so how it will work and what is the architecture and what is the main advantages. So those and all coming classes, so we'll learn more on this. Got it?
Yes, sir.
Now, if you understand, this is a visualization, right? So that is the reason. So the orally, if I explain many things, means we are forgetting. So that is the reason. Visualization means mostly we can remember. So simply if you want to understand, if you want to maintain multiple Dockers, simply you go for Kubernetes. That's it. As of now, everyone know what is Docker and how to create containers, how to create image, how to delete, how to start, how to stop. Now I want to handle multiple Dockers. So how to handle it? If you want to handle multiple Dockers, so simply you go for Kubernetes. Simply you go for Kubernetes. So Kubernetes is the orchestration tool. Kubernetes is the orchestration tool. So Kubernetes almost it is following which microservices architecture. Microservices. Okay. Now, so now let's come to here. Now if we come to here, and Kubernetes mostly it is following master and master and worker node architecture. So right, even so sir also will explain in Docker Swarm and all. So here mostly we are following Kubernetes master, Kubernetes master, Kubernetes master and worker node architecture. This is very important. In interview also many people they are asking, can you explain Kubernetes architecture? So how it will work? What are the main components in Kubernetes? So very important. So 100% they are asking. So can you explain Kubernetes architecture? So now this is if we come to here. So this is the Kubernetes master. This is the master, and these are the worker nodes. These are the worker nodes. Worker node. So this is the worker node 2. This is worker node 3. Like this we are maintaining worker nodes. This is very simple only, but try to understand. If you understand nothing, if you are not understanding, this is very difficult to understand. So worker node 1. Anyway, next 1 week we'll see same, right? We can easily understand. Worker node 1. Now this is the master and these are the worker nodes. So Kubernetes following master and worker node architecture. So master and worker node architecture. And there is many components available in master and many components available in worker node, and based on this so it will communicate each other, how master will interact with worker node, how worker node interact with your master node. So we need to understand all these components, and once you understand all these components, and later we can understand so this entire flow and all architecture. Now if we come to here, so this is the Kubernetes. So simply we are calling K8s. Many people they are calling K8s. Don't confuse here. K8s. Many people they are calling. Do you know K8s? K8s. So how many letters in Kubernetes? See, Kubernetes. How many letters? Total. Kubernetes. Kubernetes. How many letters? Total.
10,
10 letters. So in between K and S, how many letters is there?
8.
8. Simply they are calling K8s. This is the shortcut form. Don't confuse. In the industry also many people they are calling Kubernetes and few people they are calling. Do you know K8s? Even initial also, so 5 year, 2, 3, right, 4 years, 5 years back, I don't know what is K8s. If fully they are calling Kubernetes means I can understand. Okay, Kubernetes. Some people they are calling, do you know K8s? That time I am struggling. What is this K8s? So K8s is nothing but that is the shortcut form. Okay, many people they are calling shortcut K8s. The full form is Kubernetes. Don't confuse here. So this is the shortcut. And so next we are going to discuss next 1 week what is Kubernetes and what are the advantage of Kubernetes, and so what is the Kubernetes architecture, and what are the main components, what are the main components in Kubernetes, and what is the cluster and worker node setup, and what are the main objects. So this and all we can so learn next coming 1 week. Arumle bora. Okay. So now if you come to here, what is Kubernetes and how it will work? Simply Kubernetes is an orchestration engine. Right, what is Docker? Docker is a tool. Right, what is a Docker is a open source tool. With the help of we can deploy, we can implement, and we can develop your application and we can deploy with the help of containerization. And same is Kubernetes. Kubernetes is an orchestration engine, and also this is also open source platform. Right? So almost all DevOps tools are open source. I hope you know. So Jenkins, Docker, next Maven, and GitHub. So as of now, almost all tools open source only. So no need to pay anything, no need to buy anything. So all are the open source platform only. And managing containerized applications. What type of application we are going to deploy? Containers, containerized applications. Right? Docker. So with the help of Docker, here Docker also main role in Kubernetes. Without Docker, there is no Kubernetes. Without Docker, there is no Kubernetes. So in Docker, we have only limited features. But if we come to Kubernetes, we have more features. So there is a lot of features available. So anyway, we'll learn all those features and all. And also see here, so Kubernetes responsibilities including container deployment, and also we can scale up and we can also scale down and of the containers and the load balancers and all. Right, what is load balancer in AWS? So right, what is load balancer? AWS, how it will work. So there is a lot of features. These are the main responsibilities. Deployment, scale up, scale down. Now if you come to Docker, now you created one container. You created one container, right? So you created one container, Tomcat container. So this is my Tomcat container. Tomcat container. So container. I created one Tomcat container. I deployed my Java application. So just assume a Maven web application I deployed. So if we create a container, how many containers it is creating? Right? What is the command? If you use Docker run, this is a command, right? We are using a Docker run. So Docker run. Next, hmm, -d, -p. We are using port mapping and all. And I given. So this is the port mapping, and I am using so image name, and tag name colon, and we are giving a tag name. Tag name in real time 100% we are using tag name. Without tag name there is no image. So make sure that now I run this command. How many containers will create here? Only one container,
Once.
or two containers, or 10 containers?
Only once.
Only one container. Unfortunately this container is deleted. What about my application? How to access my application? Now clear? Now we know how to create containers and all. So I created one Tomcat container. In this container, I deployed my application. I can access my application. Everything working fine. So I can access my application. So access our application via browser and all. Correct? So we can access. Unfortunately, or someone is deleted this container. But how to access your application? Your application down or still it is live?
Downs.
Down. 100% down. There is no doubt here. Clear? Now, without what is the main advantage of Kubernetes? Without application downtime, if you want to deploy your application multiple times in single day, so that case we go for Docker. Kubernetes. Now Docker. You are creating container. Your application running fine. Everything we can access. In case someone is deleted, your container is not working. Your container is hanged. Your container is struggling. What about my application? How to access my application? So who will take care? Now here there is no option. Now if you come to Kubernetes, there is a scale up and scale down. There is a replication concept. How many containers you want to maintain? If one container goes down, automatically your request go to another container. And also within the seconds, it will create one more container. Hey, this container is problem. It is not working. So immediately in place of this container, it will recreate one more container. So simply if you want to understand, without application downtime, if you want to maintain your application or if you want to deploy your application, we would go for Kubernetes. That's it. Very simple answer. So there is a lot of features available. There is a deployment object, service object, and replication set, replication controller, daemon set, and namespaces, config map, secrets. With the help, there is many objects available in Kubernetes, and with the help of object, we can achieve high availability. Right? What is high availability? Scale up, scale down.
and
So
scale up
these
and
are the
scale.
terminology. These are the first try to understand, try to digest these new words. What is high availability? What is scale up? What is scale down? Okay. So these are the new words. Just try to understand. Anyway, so slowly we can understand all these words, all these terminologies and all. Now to overcome this problem, we should go for Kubernetes. That's it. Now if you come to here, this is the deployment, the container deployment, scaling, and this scaling. If you want to, we can increase, or if you want to, we can decrease the containers, and also we can maintain load balancing. So these are the some of the, and see here, actually Kubernetes is not a replacement of Docker. See here, Kubernetes is not 100% replacement of Docker. Kubernetes can consider as a replacement of a Docker Swarm. This is also one simple tool. Anyway, sir will explain coming classes. And so there is many features available in Kubernetes. So that is the reason this is the topmost. Compared to Docker, there is a Docker Swarm. Compared to Docker Swarm, this is the Kubernetes the latest one. This Kubernetes is the latest one. And Kubernetes is significantly more complex than Swarm and requires more work to deploy. And so mostly right, so Kubernetes developer, this is born in Google, and so this Kubernetes and all, it is written by Go language. So this is a Go language. It is donated by CNCF, Cloud Native Computing Foundation. In 2014, the first they developed Kubernetes. Now almost see here how many years gone, 9 years, right? Now the first version, so they released 1 point, so v1.0. Now the latest version is so v 24 or 26 latest version, which is the latest. Last batch 26.4 is there. I think now 26. Now this is the old document. This is the 18, and this is old only. Now the current is even if we Google it, we can understand it. Every 3 months or every 2 months, they are releasing one new version. Every 3 6 months, every it is updating, and you need to update the current Kubernetes version, latest 26. So the latest version is so v1.26, v1.26 latest version. So earlier this that time we are using 18 and all. Now so last so every 6 months, every 3 months they are updating, they are releasing new versions and all, and they are adding some features, and based on this we need to update. So we need to update. This is very simple only. So just try to understand. So Kubernetes is an orchestration engine, and this is a open source platform for managing containerized applications. Same like Docker, but it is not 100% replacement of Docker. And there is a lot of enhancement available in. There is a lot of features available in Kubernetes, and so this is mostly replacement of right, Docker Swarm. So Docker Swarm also it is following master, that is the master, and so worker only. So same strategy it is also following. And the next class I will explain and what is Docker architecture and how it will work. Now we can understand what is the flow. So this is very important. So next class I will explain all these components. We will get some idea so how it will work. Clear, guys? So anyone any doubt as of now? Now I hope you got some idea, right? So what is Docker and what is Kubernetes and what are the, so why we go for Kubernetes and all. Clear?
Yeah, clear, sir.
Okay. So next class, so we'll see very important Docker, sorry, Kubernetes architecture. So what is Kubernetes architecture and how it will work and what are the main components in Kubernetes. In the interview also many people, so not only many, almost so 99% everyone asking. So what is Kubernetes? What are the main components in Kubernetes? And so they are asking like, so can you explain? So can you explain Kubernetes architecture? So they are asking like, can you explain Kubernetes architecture? So next class I will explain. So for scratch level, and we will get some idea. Okay. So that's it from my side. And if we have any doubt, we can ask, or else we'll wind up and we'll connect tomorrow. Okay.